Hi dear students, welcome to our YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to take chapter 3-dimensional geometry. Let I just mention the chapter name. And from this chapter we can expect 5 plus marks. Obviously we are in PUC. See all right recording. Yeah, fine. Okay. Now this chapter primarily is actually application of the chapter vector algebra. Now you'll be seeing that. Now as soon as I start the first topic, that will be on direction cosines of a line. There it was direction cosines of a vector. So here we would like to discuss direction cosines and direction ratios of a line. The basic, that is introduction to three-dimensional geometry, is already covered in first PUC. And if you like to see the introduction part of three-dimensional geometry, you can always find in the link, that I mean to say, you can find in the description the link of the first PUC. There you can surely go through the basics. Okay, nothing but first PUC, where you have got distance formulas. Okay, and how this 3D is required, what's the reason, all I have given. Okay, I've given a practical approach where you can find the location of my head. Okay, now it is proceed. We are dealing with a line, most important, not vector. So now if I consider the coordinate axis, right-handed system, let us suppose this is x-axis, y-axis, and this is z-axis. Now, first recall position vector. What was position vector? Any vector whose initial point is origin. Correct? So we used to take a point P here, and for this vector OP, okay, let's write it here, OP for a while, OP vector. Then this vector OP is making an angle alpha. Okay, here, from here to here, it is the angle alpha with x-axis, beta with y-axis, gamma with z-axis. This alpha, beta and gamma, okay, are angles made by, okay, made by now a line with, now I'm saying by a line because now I'm going to extend the backward also. Now it's a line, not a vector now. So alpha, beta, gamma are angles made by a line with the positive direction of x-axis. Positive direction of coordinate axis. Coordinate axis, which are those, namely x, y, and z axis respectively. When I say respectively, alpha with x-axis, beta with y-axis, and gamma is angle made with the z-axis. So alpha, beta, gamma are angles made by a line with positive of x-axis are termed as direction angles. So what are direction angles? Angle made by the line along with the positive direction of x, y, and z axis. And now comes direction cosines. What is this direction cosines? It is the cosine of alpha, cosine of beta and cosine of gamma, which we denote as L, M and N, are known as direction cosines. And the relationship between direction cosines is given by cos square alpha plus cos square beta plus cos square gamma is equal to 1. In vector algebra, I actually have derived it, okay? Or cos alpha, as we know, it is L, cos beta is M, and then cos gamma is N, nothing but L square plus M square plus N square should be equal to 1. Fine. This all we know. Now see, let us try to understand the directed angle in the reverse direction of the line. Now it is a line. Reverse direction of the line, nothing but this direction, and here I'll take P dash. So in the reverse direction, what could be the angle? Now see carefully, observe carefully. See, now here x-axis is this. Now here also one angle is made with the reverse direction of the line L with the x-axis. What could be the angle? For that, analyze carefully. See, this is a straight line. Angle of a straight line is 180 degree. Now in that 180 degree, see this from here till here. Just see from here till here. What's the angle? 180. But I want only this angle. Correct? No, I want only this angle. So from 180, from here to here, the angle is removed, nothing but pi minus alpha. So in the reverse direction of the line, I can say that in the reverse direction, angle made by the line with the positive direction of x-axis again, okay, again with its positive direction of x-axis itself, but angle is pi minus alpha. But whereas in the usual direction, it was alpha. Now in the reverse direction, it is pi minus alpha. You can see if I add pi minus alpha with alpha, minus alpha plus alpha will get cancelled, get pi, nothing but the angles are supplement. So we can just comment in the reverse direction. So you can take as first number 1, point number 2, point number 3. Now point number 4, in the reverse direction, the line L, here also made a line by L, okay, L makes an angle pi minus alpha, pi minus beta. Here also, no, as I said pi minus alpha, by symmetry I can say, see with y axis it is beta. So again from here till here I have to go, nothing but here beta already gone, from here to his what? From here to it is this 180, in that pi, from here to here it is pi, in that beta is removed, so pi minus beta. Similarly pi minus gamma for z axis. So in the reverse direction, the line L makes an angle pi minus alpha, pi minus beta and pi minus gamma with the coordinate axis, with the positive direction of coordinate axis, positive direction of coordinate axis. So coming to vector, we had only one direction cosines, that is element, but here we have a pair. Let us see which is that other pair. Means the first one is here, what is cos alpha, cos beta, cos gamma, which is the other one. Okay, so but first we have talked about direction angles of the coordinate axis, namely what again same, namely x, y and z axis respectively. I hope till here the things are very clear. Again, these are directed angles only, direction angles only, but in the reverse direction. Okay. Now, let I mention that this are again what? Direction angles. Just mention here direction what's the time? Angles in reverse direction. In reverse direction. of the line. Okay. Now, what about the direction cosine? Very simple. See, as soon as we got directed angles alpha, beta, gamma here, for that what we did, we took cosine. That we call direction cosines. Similarly here, direction cosines. Direction cosines in reverse direction. In reverse direction of the line L. See carefully. Now cosine on this, if I take what is cos of pi minus alpha, recall ASTC rule. In second quadrant, pi minus theta. In second quadrant, only sine and cosecant are positive, remaining four are negative. So here this cos will get minus cos alpha, which is nothing but minus L. Don't forget cos alpha is L. So it is now minus L. Next, cos beta, nothing but cos of, I mean to say pi minus beta. It is again second quadrant minus cos beta, nothing but minus M. Similarly, cosine of pi minus gamma, nothing but minus cos gamma, nothing but minus N. So we can say that for every line we are going to have pair of direction cosines. So I can just comment here as a note. Every line has a pair of direction cosine, pair of direction cosines, namely first one will be L, M, N, another will be minus L, minus M and minus N, and this always will obey in this condition itself. So this is regarding direction cosine of a line. Okay. So it also means that, who knows, for one marker question, they may frame one question, if direction cosine of the line is 1 by root 3 minus 1 by root 3 and 1 by root 3, what could be in the reverse direction? Just you have to change the sign. So in the reverse direction, the answer will be minus 1 by root 3, from plus to minus, and here it's minus to change to plus, and here from plus to change to minus. But before you do so, no, just sum the square. Take the square of this, means take the square, take the square, take the square, and add all the three. It should give us what? 1. Only then is a direction cosine. If it's not equal to 1, it's not a direction cosine, and you can see very clearly, 1 by root 3 square. If I take the sum of the square, get 1 by 3 here, minus 1 by root 3 the whole square is plus 1 by 3 again. Again, this is plus 1 by 3, which will give us what? 3 by 3, nothing but 1. If I given some other number where it is not sum of the square, then the answer should be none of these, nothing but the direction cosine doesn't exist. Okay, so I hope this point is very clear. Let us try to talk about direction ratio now. Kindly make a note of this. Dear students, we have to understand one more thing. See, coming to direction cosines of a line, where we had pair of direction cosine, where in one direction we have got element, in reverse direction we have minus L, minus M and minus N. And direction angles, in one direction we have alpha, beta, gamma. In reverse direction we have got pi minus alpha, pi minus beta and pi minus gamma. For the light is not on. Oh. Yeah, pi minus gamma. So having known this, so one doubt will be there, that all the lines did not pass to the origin. If all the lines are not passing the origin, for example, I have got one line here, then how are we going to find the direction cosine of the line L dash? So very simple. We are going to apply our Spurious logic. See this carefully. See this carefully. I have got a line here and one more line here, and this are corresponding angles, correct? And we know from school days, if this is angle some let's suppose theta, and this is some angle beta. So since this is corresponding angle, so angle theta and beta are same. So applying this logic, why these angles are same? Because we have got these two lines parallel. So whenever we want to find the direction cosine direction angles of this line L dash, which is not passing to the origin, we can always draw a line parallel to this but passing to the origin. As soon as the line is passing to the origin, I can find what direction angles as well as direction cosines. And this line will also have the same direction cosines as well. I hope this point is clear. Okay. So whether the line is passing to the origin or not, we can always have direction cosines because of this logic. Now let us try to also understand about direction ratios. Now what are these direction ratios? Any number, let us suppose A, B and C are said to be direction ratios if they are proportional to any number A, B, C, which are proportional to direction cosines. Proportional to direction cosines. And some authors also call this as direction number. Direction ratio is also known as direction numbers. Okay. Now see carefully. For this, let's have capital A here. Any number ABC which is proportional to direction cosines, which are those L, M, N. So L, the direction cosine, and the direction ratios should be proportional. So having this logic, L by A should be equal to M by B should be equal to N by C. All should be equal to some constant K. Let us try to understand what is this constant K. For that, let us recall that we know the relationship between direction cosine, that we know that L square plus M square plus N square is equal to 1. Solve for L here. So if I equate to the corresponding, all are equal to the constant K. So I'll get L by A is equal to K, which implies L is equal to A times of K. Similarly, if I take M by B and K, cross multiply B, I'm going to have M is equal to B into K. And lastly, N will be equal to C into K. Let us take it as equation number 1. So in place of L, we have A into K. Don't forget, our motive is to find what is the value of K. What is the proportional value? When we are saying what is the proportional value for which these ratios are equal. So L is A into K, the square, then M is B into K square, N is C into K, the whole square is equal to 1. Now giving first square for each, so I'll get A square K square plus B square K square plus C square K square is equal to 1. In this common is K square here. So we are going to have K square of remaining is A square plus B square plus C square is equal to 1. Part of 2 term I can cross multiply this. So we are going to have K square is equal to 1 divided by A square plus B square plus C square. On taking the square root, we are going to have K is equal to plus or minus 1 divided by square root of, this is square minded, A square plus B square plus C square. So the constant which we are saying that this ratio will be equal to a particular constant, I think, but they are proportional. That constant is K equal to plus or minus 1 divided by root of A square plus B square plus C square. Okay. And if you just see very carefully, since we have taken direction ratio, let's comment here. Since we have taken direction ratios to be A, B, C, if you think with respect to a vector concept, this is A cap plus BJ cap plus CK cap. Magnitude of this will be root of A square plus B square plus C square. That's what you can see it here. I think it was the length of the vector if we talk with respect to vector. So it's a reciprocal of length of the vector. Okay, so it is always proportional to plus or minus, and we are going to listen plus or minus as we discussed. We are going to have pair of direction cosines for a given line. Okay, and from here we can also talk about one more thing, that from here direction cosine, if you have got ABC to be direction ratios, direction cosine can be obtained by A. See, direction cosine, you see, L is equal to A into K, M is equal to B into K, and N is equal to C into K. If I put in equation number 1, so from 1 we are going to have direction cosine to be what? In place of this, yeah, L is A into K. K is what? Plus or minus 1. So 1 into A will be A, so I'll get plus or minus A divided by root of A square plus b square plus c square. Similarly, m will be equal to, yeah, for this m plus b into k. K is what? Plus or minus 1 divided by, so plus 1 into b will be b, so plus or minus b divided by square root of a square plus b square plus c square. Lastly, n will be equal to, again, c into plus or minus 1 will be, I'll get c here, divided by root of a square plus b square plus c square. So from direction ratio, how to obtain direction cosine, that also one formula is given to you, and this is same like vector. What we used to do in vector, how to find direction cosine, we used to find unit vector. Nothing but vector by its magnitude. So if I talk about this as a component of vector A, it is ai cap plus bj cap plus ck cap. I'm just trying to relate this one to vector chapter. So you can see, no, scalar component, I scalar component, j component, and k component divided by its magnitude. But here we have a plus or minus, which we never used to have in vector, because vector was only one direction, but line we have got two directions. Okay, so I hope this is clear. So here I have commented that if I know direction ratio, how are you going to find direction cosine? So if DRS is given, then direction cosine is given by this formula. Okay, kindly make a note. One point I want to comment here, that coming to a line we are going to have pair of direction cosine, whereas coming to direction ratio we are going to have infinitely many direction ratios. And coming to here we have got pair of direction cosine. Depending on the problem, you can think of taking positive or negative. Okay, fine. And lastly thing is, coming to direction ratio, if I say ABC is a direction ratio, and if I take k into A, k into B, and k into C, or if ABC are direction ratio, I can also have lambda into C, means lambda into A, lambda into B, and lambda into C, where lambda is not equal to 0, to be one more set of what? Direction ratio. But you can see, if I divide this, it will be proportional. Okay, so we can have infinitely many, but lambda is not equal to 0 there. Fine. So having this, let us try to discuss now direction cosines of coordinate axis. Kindly make a note. Now, dear students, let us try to understand the direction cosines of the coordinate axis. So direction cosines of coordinate axis. See, if I talk about x-axis, any point lying on x-axis is of the form x comma 0 comma 0. So since I'm talking about direction cosine, we know the direction cosine relationship is what? L square plus m square plus n square is equal to what? 1. So any point lying on the x-axis from x comma 0 comma 0, so it will be L comma 0 comma 0, since I want direction cosine. So I want to know what is the L value here. So put here L square, m value. See, this m and n both are what? 0. So 0 square plus 0 square is equal to 1, or L square plus 0 square plus 0 square is what? 0, plus L square is equal to 1, or L is equal to plus or minus 1. Therefore, I can say the direction cosines of x-axis is plus or minus 1 comma 0 comma 0. So you can see on x-axis L value is plus or minus 1. So like this, if I go for y-axis, you can see here only, this will be 0, this will be m square as it is, this will be 0. So solve for that, m square is equal to 1, nothing but m is equal to plus or minus 1. So I can say direction cosines of y-axis is 0 comma plus or minus 1 comma 0. Point number 1, point number 2. Similarly, direction cosines of z-axis is 0 comma 0 comma plus or minus 1. These all are very important for 1 marker. Now moving on to our fourth point, direction cosine of positive x-axis is, see, when I talk about only x-axis, don't forget our x-axis also have got a negative direction here, correct? Like this, correct? This is x dash. So here one direction, and this is the reverse direction. That's what here. This side will have plus, and this side will have a negative. That's what both are taken into consideration for all x, y, z. Now, if I talk about only positive part of x-axis, since here only positive values are there, so in place of plus or minus 1, it will be only 1, 0, 0. Similarly, direction cosine of positive y-axis is 0, 1, 0. Then for positive z-axis, the direction cosine be 0, 0, 1. Next, direction cosine of negative x-axis is minus 1, 0, 0. Eighth point, direction cosine of negative y-axis is 0, minus 1, 0. This is minus minded. And last point, direction cosines of negative z-axis is 0, 0, minus 1. Okay, this will be a very handy result. And we have to also go for the equation of coordinate axis. When I'm going to take equation of coordinate axis, then there I'll be using again this fact there. So kindly make a note of this. Okay. Now let us try to understand direction cosine of a line passing through 2 points. Okay. And don't forget, through 2 points, only one line can pass. So direction cosine of a line passing through 2 points. See, this is actually same like in vector, no? Vector joining 2 points we had. x1, y1, z1 and x2, y2, z2. We took the coordinate and the point was p1 and p2. Okay. So same thing here. But here in the form of what? A line. So here we have got x-axis, then here y and followed by z-axis. We have a line. And this line coordinate P is x1, y1, z1, and the coordinate Q is x2, y2, z2. And I want to find the direction cosine of a line passing through this 2 point. So I want to know the direction cosine of this line PQ. Now again, to find direction cosine, first I should have direction angle. Nothing but the line should pass through the origin, and you should have some angle between x, y, and z axis. As I discussed previously also, every line need not pass through the origin. You can always draw a line parallel to this, passing through the origin, and then we can have the angle alpha, beta, and gamma. And for that we can have cosine angle. Cosine, if I take, I'll get direction cosines. Now, having understood that, surely we are going to have what? Direction angles. There is no doubt about that. Now, small construction I am doing here, perpendicular drawn. Let's suppose this is Pn. Now see, here, if I just try to take the same graph here, small one, there is a coordinate axis. Here it is x, then here it is y, and here it is z, and here we have p here, and here we have q. Okay. Now see carefully. I'm only taking this part. Okay, p, q, n. I'm taking it here. And if I just draw a line parallel to z axis here, okay. Now, since the angle made by the line with z axis should be what? Gamma. So that angle whichever has been made by this line with the z axis should be gamma. So I can just take it here. How is it? See, if I extend here, there's some angle made. So corresponding angle is about same. And again, one more thing, don't forget, I can draw a line parallel to PQ somewhere here, correct? And then there's an angle formed here, gamma, correct? Now since this is parallel, there's an angle here, gamma. Do you agree with this? I repeat again, PQ line, I'm drawing a line parallel to PQ line here to have a direction angles, and the angle made by this line with the z axis gamma. And again, this is corresponding element. So you can see L shape here also and here also. So since the angle is gamma here also this is what? Gamma. And again, this line is parallel to this. So alternate angles are same. So I can see gamma here. And one more thing, you see this angle is also gamma. How, sir? Can you see this? Alternate angle, school days, see? So whatever the angle is there, same angle should be there here also. So gamma. So I can say that that angle is gamma. So many things are involved. I hope this point is clear. Now I want to know what is cos alpha, cos beta, cos gamma. So I'll take only cos gamma, and I'm behind z axis because some school days we are dealing with the x axis and y axis. I thought let us have interpretation with respect to z axis. Same thing we are going to generalize, okay, to the other things. Now see carefully. Since I want direction cosine, so cos gamma I need, and this gamma is opposite to this. So I want only this and this 90 degree, nothing but q and I want, and this is 90 degrees, so hypotenuse will be this. So coming to cos gamma, it is adjacent, that is qnq or qn divided by the hypotenuse is pq. Now see carefully, qn, is it now this small n qn is actually, okay, first let's join this. Okay, so okay, R here and S here. See carefully, is it not, as we know from our school days, recall, if I have got in 2 dimension x here, y axis here, if I take any point x comma y, always the vertical length is, this length is PA, is given by y coordinate. Since in first quadrant all are positive, x and y is positive, so there is no need of mod, or any will take mod here. Similarly, this is all x, y is a positive octane. We have got 8 octane, this is in first octane. So as you can see, this vertical length is corresponding to this axis present here, remote y axis. Since it is y axis, y coordinate here. Now here is z axis, so the z coordinate is z2. So the length from here till here is z2. Similarly, p of x1 comma y1 comma z1. So from here to here the length is what? z1. And this we can see is a rectangle. Which one? P, N, S, R. Opposite side of rectangles are equal. So I can say that even this length is also z1. Don't forget, I want only this length. See, for example, this cap. I want to know this length. So how you'll find? From the entire, remove this, correct? I want this length. From entire, remove this, correct? No? Visible. So I want only this length. So for this length, from entire, nothing but QS, remove NS. From entire, remove NS. When I was the entire length, Z2. So this length will be, now only this length will be from entire Z2, remove this length, what is that? Z1. So this length Qn will be Z2 minus Z1. So Qn is what? Z2 minus Z1 divided by PQ. This will be cos gamma, nothing but the direction cosine. Okay. The remaining direction cosines generalize. See, gamma is angle made with z axis. So the numerator is what? Difference of z coordinate divided by PQ, nothing but the length of the line PQ. Correct? Na? So here, from here you can say cos alpha and cos beta. Similarly, we can write cos alpha. Alpha is angle with the positive direction of x axis. So since for z axis, it is difference of z coordinate. So here it should be difference of x coordinate divided by PQ. Similarly, for cos beta, it is y2 minus y1 divided by PQ, where PQ is what? I want to know the length of PQ. I have to apply distance formula. So by distance formula, PQ is equal to square root of x2 minus x1 plus y2 minus y1 plus z2 minus z1 the whole square. This will be the direction cosines. Therefore, the direction cosines are what? X2 minus x1 by PQ, comma y2 minus y1 by PQ, comma z2 minus z1 by PQ, where PQ is given by this above expression. Okay, and coming to this, we can also have direction ratio. Direction ratios can be either x2 minus x1, y2 minus y1, z2 minus z1, or every line will have pair of direction cosine. No, so I can have direction ratio as x1 minus x2, y1 minus y2, lastly z1 minus z2. Okay, both are correct. Kindly make a note. Dear students, now let us solve question paper problem that is issued by KSEAB, that is PU board. Okay, and for the academic year 2025 to 2026. So these two questions are confined to the first exercise of three-dimensional geometry chapter. So from model question paper number 2, a one marker question, multiple choice question. Question says a direction ratios of x-axis. See, I just discussed direction cosine, and I took L comma 0 comma 0 because lies on x-axis. L I took because my intention was to find direction cosine. Now, since we want direction ratios, as we discussed, we have infinitely many direction ratios for the given line, and even x-axis is also a line. And any point lying on x-axis is of the form x comma 0 comma 0. So in place of x, I can have any other alphabet also, but y and z coordinates should be 0. And you can see in all the option only here, these two coordinates are 0. Okay, this is non-zero, or k can be 0 also, non-zero also, no problem. So C. So this will be the direction ratio of x-axis. Option C is correct. Similarly, for y-axis, as a note, we can have direction ratios of y-axis will be 0 comma k comma 0, and direction ratios of z-axis will be 0 comma 0 comma k. As a note, we can remember. Now coming to next question, again a one marker problem from model question paper number 3. If a line makes pi by 2, 3 pi by 4 and pi by 4 with xyz axis respectively, then its direction cosines are. Okay, so this is the angle made with coordinate axis. So this is our alpha, this is our angle beta, and this is gamma. So coming to the solution of this, cos alpha. So alpha angle is pi by 2. What is cos 90 degree 0? If you see the option, option C straight away ruled out because 0 is not there yet. But option A, B, and D contains 0. Next is 3 pi by 4. So cos beta, and beta is given as 3 pi by 4. So using allied angle concept of first PUC, we can write this one as cosine of acute angle is pi by 4. So we can write pi by 4 here, and then pi with subtraction. So pi minus pi by 4 will be 3 pi by 4 lying in second quadrant. In second quadrant, don't forget only sine and cosecant are positive, remaining 4 are negative. Here we have cos, so it is negative of cos pi by 4. Cos pi by 4 is 1 by root 2. So minus 1 by root 2 is the direction cosine. You can see here that is there only in these two options. So option D is ruled out. Now the last thing is cos pi by 4. That is cos gamma. So cos pi by 4. What is cos pi by 4? 1 by root 2. So we have got 1 by root 2 here, minus 1 by root 2 here, 0. So 0, minus 1 by root 2 and 1 by root 2 is there in option A. So option A is correct. Kindly make a note of this. Dear students, one small correction. Problem is correct, don't worry. This is question number 13. Okay. Fine. Kindly make a note. Dear students, now let us move on to a 3-marker derivation, and it's also our next concept, that is equation of a line in space. So equation of line in space, and this question has been asked in model question paper number 1, and it's a 3-marker question. So the derivation is we have to derive the equation of the line in space passing through a point and parallel to a given vector in vector form. We have got both Cartesian and vector. Before I go ahead, let us try to understand what they are saying here, that it passes through a point and parallel to a given vector. Why it is that there are two conditions. One is a point, other is a parallel to a given vector. See this carefully. See, when we talk about a line, even 2 dimension, that is straight line, chapter number 9 of first year PUC, there also we were talking about, I hope it's recording. Yeah, recording. Always, no? Okay, fine. Let's come back. So we want to find the equation of a line Even first PUC also, coming to chapter straight lines in 2 dimension, chapter number 9 of first PUC, we always talk about uniqueness. And through 2 point only one line will pass. But here this derivation is not talking about 2 points to which the line is passing. It's talking about it's passing through a point and parallel to a given vector. See, let us try to break this. If I say draw a line passing through a point A, known point, how many lines can pass through this? See this? 1, 2, 3, 4, 5, 6, 7, infinitely many lines can pass. Okay, this is the first condition which they gave, which I'm breaking. First, it was passing to a point. Next, parallel to a vector. Second, if I talk about I have got a line and I'm going to draw a line parallel to this vector. How many lines can be drawn parallel to this vector? See this, one line here. Wait, it's not taking parallel. And now, yeah, one line, one more line here, one more line here. Like this, I can draw infinitely many lines which are parallel to this. What I mean to say is, when I take a point and a parallel vector separately, I can have more than one line passing through a point A and having infinitely many lines parallel to this vector. Let us suppose vector is B. So uniqueness is not achieved. So if I take third, means what? I will combine this, nothing but it should pass through a point A and it should be a parallel to this vector B. Okay, as soon as I say it should, I'm combining both the condition. I'm using the word and, both should happen. So a line should pass through this point A and it should parallel to this vector B. Just see here, if I'm just going like this, it passes but it's not parallel, you can see it's intersecting. And if I draw a line somewhere here, this line is parallel to vector B but not passing to the point A. So the only one possibility is this. This is the line L, unique line, one line which is passing through a point A and also parallel to vector B. So can you see, two useless things combined together to get a unique result. So useless is also important when we use in a proper way. Okay, fine. So you want uniqueness of the line. So the only one line which can be drawn is this blue color line, having a condition that it should pass to the point A and parallel to the vector B. So just for your information why the two conditions are imposed. Now let us start with the problem, means the derivation. See, now we are going to take the coordinate axis. So let us say that this is our x-axis. Okay, y-axis I have taken so far, so I'll take right-hand system y-axis here. Then this is our x-axis. Then here we have got z-axis, and here is the origin. Okay, they are mutually perpendicular. Yeah, it's just looking perpendicular, and there is a line, and this line L is passing through a known point, and that known point is capital A, whose coordinates are x1, y1, z1. Okay, and this line have got infinitely many points on the line, and that care is taken care by the coordinate P, x, y, z. Don't forget, even in school, means first PUC also, in 2 dimension, when you have x, y, and the known point is x1, y1 or x0, y0, whenever we give the index for this point, no, x1, y1, z, the index, those are known point, those are particular point, those are given point. Whereas this is a general point which will take care of each and every point on the line, because don't forget, on the line we have infinitely many points. Okay, and these 2 points we can join from the origin. So here I'll join, and again I can join this, and now I give an arrow mark. It becomes a position vector. What is a position vector? Any vector whose initial point is origin. So this OA is a position vector whose I will take a small vector A, and for OP, for the point P, the position vector is OP, and I will take as vector R. And for this line there is a parallel vector B. Make sure when you are drawing, both should be parallel, and this vector B is given as AI cap plus BJ cap plus CK cap. Okay, now diagonal will carry 1 mark. Make sure it should be correct, and many students will forget to draw B, vector B. Okay, and both should be parallel. Okay, Now let us proceed from the figure. So coming to the proof or the solution, whatever. So from figure, it's very clear that vector AP, yeah, this vector AP is parallel to vector B, and you have to discuss the figure very easily. You can discuss the figure. Consider line L passing the point A, whose position vector is vector A with the coordinate x1, y1, z1, and a general point P with the coordinate x, y, z, and having a position vector R, and is parallel to vector B, whose direction ratios are A, B, C. Whatever is there in the diagram, that's you have to say it. That will give you the description marks. Now vector AP. Coming to vector algebra chapter, is it not vector AP is vector join 2? Vector AP is parallel to vector B. So whenever two vectors are parallel, is it not one vector is scalar multiple of the other? Where lambda is any real number, obviously non-zero real number it is. And vector AP, from here vector AP is a vector joining 2 points. So from vector algebra chapter, vector joining 2 points is the first letter, is the second letter. So it is vector OP minus vector OA is equal to lambda times of vector B. What is vector OP from the diagram? It is vector OP is vector R. And what is vector OA from the diagram? It is vector A is equal to lambda times of vector B. I want the general point P. So solve for vector R. So transpose this. We are going to have vector R is equal to vector A plus lambda times of vector B. This will be the equation of a line in which form? Vector form, where lambda is any real number, and I can also say it's a parameter. Why do we say it's a parameter? Because for different values of lambda, we can get all the different points on the line. So this will be the equation of the line, where vector A represents, let us write it here, where vector A is position vector of the point capital A with the coordinate x1, y1, z1, that is this, and vector B, which is equal to what? AI cap plus BJ cap plus CK cap is a vector collinear or parallel to the line L, and since they are parallel, direction ratio of the vector B and L both are same. Width and direction ratios of the line L is what? ABC, A comma B comma C. And already we have discussed, if I know the direction ratio, how to get direction cosine also. Now this derivation is completed. For exam point of view, since they have asked only in which form? Vector form, it is done. Now I would like to extend to Cartesian form, and as I said, I want to complete each and every concept. Now your derivation is done. For 3 markers, this is what you are going to get along with the description. Now you see carefully. Coming to Cartesian form, I want to get the equation of a line in Cartesian form. Again, let us say till here for exam point of view done. Okay. Now see carefully Cartesian form. Now coming to Cartesian form, see I have to get rid of these vectors. What are the vectors are there? Vector R, vector A, vector B. Vector R is taking care of point P. So point P is x comma y comma z. So from here I want what is vector OP, nothing but vector R. Vector R, I hope it's recording. Yes. Vector R is equal to vector OP is equal to, yeah, xi cap plus yj cap plus zk cap. Next, vector A. Vector A is taking care of the point A. So point A is x1 comma y1 comma z1. So vector OA, see carefully, the point OA is taken care by vector A, and I will just write vector A here. Next, so now x1, y1, z1. So it's what? x1 I cap plus y1 j cap plus z1 k cap. Converting the point to vector form and vector to point, we have all discussed in vector algebra chapter in the concept of component of vectors. So whenever you have got any point given to you, the first coordinate is x, second is y, and third is z. For x, it will along x-axis it is I cap, along y-axis j cap, along z-axis k cap. Unit vectors will be there, that we have already discussed. And then point means vector b. I mean vector b, and vector b is a I cap plus b j cap plus c k cap. All this we are going to put in equation number. This we will regard as equation number 1. So let us put in equation number 1. If we do so, vector r is here. Vector is xi cap plus yj cap plus zk cap is equal to vector A, is equal to vector A. Vector is here. x1 I cap plus y1 j cap plus z1 k cap plus lambda times of vector b. So plus lambda times of vector b is here. That is a I cap plus b j cap plus c k cap. Okay, now let us simplify. As I said, we want Cartesian form. When I say Cartesian form, I should be free from the vectors. So let us try to simplify. So here there is not much change. Plus now multiply the scalar to each of them. Lambda into a, lambda into b, and lambda into c. So I get lambda a I cap plus lambda b j cap plus lambda c k cap. Now how to add any two vectors? We know I with I, j with j, k with k. So when I talk about I cap, see here x1, and here is lambda a, then plus j cap, here it is y1, and here it is plus lambda b. Okay, then plus k cap multiplies z1, and here is lambda c plus lambda c is equal to the left hand side xi cap plus yj cap plus zk cap. Now see, on either side we have got vectors. Let I highlight this. On either side we have vectors. Now I can think of equating on either side the I, j and k scalar components. So on equating the components, both the sides. Here the component of I, the scalar component is x. Here it is, see, I component is x, and here it is x1 plus lambda a, okay, comma, then j component here y, and here it is lambda by y1 plus lambda b, and k component here z, and here it is z1 plus, sorry, equal z1 plus lambda c. See, as I said, lambda is a parameter, so I want to eliminate the parameters to solve for lambda. And you can see when I'm equating, I have made sure that I'm free from I cap, j cap, k cap. I think, but we are free from the vectors. Now we have come to Cartesian form. Now let's try to obtain the line equation. So if I just transpose this, solve for lambda. So x minus x1 is equal to lambda a, or cross multiply a here. I'll get x minus x1 divided by a is equal to lambda. Similarly, solve for lambda here, transpose this, y minus y1 is equal to lambda b. Cross multiply b here, y is equal to y1 divided by b is equal to lambda. Why we cross multiply? Product of two terms. And again transpose this, z minus z1 is equal to lambda c. Cross multiply c here, z minus z1 divided by c is equal to lambda. Therefore, equation of a line is x minus x1 by a is equal to lambda. But what is lambda? Y minus y1 by b is equal to again lambda. But what's lambda? Z minus z1. Write properly. Z minus z1 by c. So this is the required equation of the line where x1, y1, z1 is a point on the line, or is a point to which the line is passing, and the denominator a, b, c is the direction ratio of the line, and a, b, c is direction ratios. Direction ratios of the line. Direction ratios of the line. Okay. I didn't have space to write of the line, so let us just write it here. Direction ratios of the line. Now here, most important thing to be understood by you, as soon line equation is given both in vector and Cartesian form, just by seeing we can comment what is the direction ratio and direction, I mean to say what is the direction ratio and the point on the line. Coming to vector form now, see we have got two vectors. This is any general point on the line, this vector represents general point on the line. But as soon as you see the right hand side, the vector b, which is multiple of a scalar, that vector represents a parallel vector. So it means the vector having a scalar multiple will have direction ratio of the line as well as the vector. Whereas this vector is not a multiple of any scalar, so this will represent a point on the line. So again I repeat, just by seeing in vector form how to comment, it's a direction ratio of the line, which vector represents direction ratio of the line and which vector represents point on the line. The vector which is representing point on the line will not be a multiple of any scalar. Whereas the vector which is vector b, which is representing direction ratio of the line, will be having a scalar multiple. I hope this point is clear. Coming to Cartesian form, see direction ratios are ABC, that is a denominator, provided x multiple, y multiple and z multiple in numerator are positive 1. You can see here x multiple is positive 1, y multiple is also positive 1, z multiple is also positive 1. So whenever in Cartesian form you want to know the direction ratio, first make sure x, y, z multiples are 1, positive 1. Then the denominator represents direction ratio of the line. Okay. Whereas the point, see point was x1, y1, z1, that is a numerator, x1, y1, z1, but with a minus sign. So it means if at all you want a point, just here, from here x1, minus y1, minus z1, when I want a point, we have to change the sign. What do you mean by that? See, here sign for x1 was negative, y1 is negative, z1 is also negative. When I'm writing the point, I have changed the sign from negative to positive, positive and positive. Similarly, let us suppose that equation of line was given something like this: x minus x1 by a is equal to y plus y1 by b is equal to z minus z1 by c. I want a point of this line. Very simple. Change the sign, I said no. So here sign of x1 is negative, so change to positive. Sign of y1 is positive, change to negative. And sign of z1 is negative, change to positive. This will give you the point on the line. Okay, like small change. No, I don't want you to go, well, solve the problem, I'll take this equation, compare. No, as soon x, y, z multiples are positive, direction ratios are the denominator of the given line, and the point on the line is the numerator. Just we have to change the sign from positive to negative and negative to positive. Since here all are negative, change to positive. I took just one example. Here negative, positive, negative. So it will be positive, negative, positive. Okay, I hope this point is clear. Fine. So this is just for your understanding, I've said. So derivation will complete here only, but we require all. Kindly make a note. We'll start with the next concept. Dear students, having understood the concept of equation of a line and deriving the equation of line both in vector and Cartesian form. Now time has come to solve the problem on the same. So from model question paper number 1, a 1 marker question, question number 30. Question says the Cartesian equation of a line is x minus 5 by 3 equal to y plus 4 by 7 equal to z minus 6 by 2. Then the vector equation is, we want the vector equation of the line. And don't forget, vector equation of the line is given by vector r is equal to vector a plus lambda times of vector b, where vector a stands for position vector of the point lying on the line and vector b stands for a parallel vector. And coming to Cartesian form, after making sure that x multiple, y multiple and z multiple are 1, the point on the line is there in numerator. Just you have to change the sign. So here it is minus 5 plus 4 and minus 6. The point will be now 5, minus 4 and 6. And point we have taken as capital A. So I have just taken this numbers and I have changed the sign. Negative to positive and positive to negative, as we discussed in the derivation. And vector b is there in denominator, the direction of the line. So the answer will be from here vector a 5i cap minus 4j cap plus 6k cap plus lambda times of vector b here. So denominator of x 3, so 3i cap, denominator of y, that is 7, it is plus 7j cap, and lastly for z denominator is 2, so 2k cap. So this will be the equation of line in vector form. So which option is matching with this? 5 minus 4 6, okay, and 3 7 2. Option C is correct. Okay, now moving on to the question number 28 from model question paper number 2, a 2 marker question. Question says find the vector and Cartesian equation of the line passing to the point 5 2 minus 4 and parallel to this vector. So see this carefully. They have said passing to the point. So this is given as what? Point. So point is the capital A, which is given as 5 2 minus 4 and parallel to this vector. So this is our vector B. So since I want both in vector and Cartesian form, so from here vector A will be 5i cap plus 2j cap minus 4k cap. We know that equation of a line in vector form is given by vector r is equal to vector a plus lambda times of vector b. Vector a is here, that is 5i cap plus 2j cap minus 4k cap plus lambda times of parallel vector b, that is given here 3 2 minus 8. So 3i cap plus 2j cap minus 8k cap. This is the equation of line in vector form. Now let us try to write down the Cartesian equation of line. So Cartesian equation, and it is Cartesian equation of the line. Equation of the line, I mean to say equation of the line in Cartesian form is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c, where x1 y1 z1 stands for the point, represents a point lying on the line, and the point is given as 5 2 minus 4. So x1 y1 and z1, and abc are the direction ratio of the parallel vector, that is here. This is our point, means abc. This is a, the scalar component, direction ratio, and b, and then c. Okay, let's substitute here. X minus x1 is 5 divided by a is 3 here, is equal to y minus y1. Y1 is 2 divided by b is again 2 here, is equal to z minus z1. Z1 is minus 4 divided by c. C is minus 8. So we are going to have the equation of the line to be x minus 5 divided by 3 is equal to y minus 2 divided by 2 is equal to z minus minus plus 4 divided by minus 8. So this will be the equation of the line in Cartesian form. Okay, kindly make a note of this. Dear students, now let us move on to the next concept, that is angle between the two lines. Before that, let I comment one thing here. See, coming to equation of a line, no, we had equation of line in Cartesian form as x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c, where this a, b and c are the direction ratio of the line L, this line L. Okay. Now let us suppose in place of direction ratio ABC, we have been given direction cosine, that is LMN. Then the equation of the line with direction cosine L, M and N is given by x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N. And don't forget, last class we also discussed the direction ratio and direction cosines are what? Proportional. Okay, so it also means that from here, let us suppose I want direction cosine of the line, I can just divide the denominator by square root of a square plus b square plus c square, divide this in denominator. So denominator should be divided by this term, and as I divide the a by root of this, then b by root of this and c by root of this, I get LMN. Okay, I just wanted you to have this point as well. This is also equation of the line L, provided I know direction cosines. Okay, fine. Now let us make a note of this. Now let us move on to angle between two lines, the next concept. Angle between two lines. Recording, no? Yeah. Angle between two lines. Focus, pay attention, listen carefully. Ready? See, let us again consider the coordinate system. We have got a 3-dimension. This is y-axis, x-axis, the origin, and here we have, yes, perpendicular looking z-axis. Now I've got two lines, and the line is, this is the first line passing the origin, and there's one more line passing the origin. And this line, suppose this is L1 and this is L2. L1, I've got one point P, whose coordinates are A1, B1, C1. And this line L2, okay, is having a point Q whose coordinates are A2, B2, C2. Okay, and here we have got an angle theta between the line L1 and L2. I want to find the angle between the lines L1 and L2. Now, if we just see from here, no, yeah, this is L1 and this is L2. But if I just see from the origin, from here, now you see a narrow mark here. So it is, if I give a narrow mark here also, no problem. Okay, OP1 and OP, I repeat, OP and OQ is a vector. OP and OQ is a vector, so only confined in this direction. And we know angle between the two vector, cosine angle is given by vector A dot B divided by magnitude of vector A into magnitude of vector B, where theta is the angle between the vector A and B. So having this formula, this concept, we can say the cosine angle will be, now since theta is angle between A and B, so I have taken dot product divided by its magnitude. Now since theta is angle between OP and OQ, so I can say vector OP dot vector OQ divided by magnitude of OP into magnitude of OQ. Okay, so this will be the cosine. Now here OP dot OQ, recall, for dot product we have to multiply I with I, J with J, K with K, nothing but x with x component, y with y component, and z with the z component. So it is a1 a2 plus b1 b2 plus c1 c2. Okay, c1 c2 divided by mod of OP, nothing but magnitude of this. This is given by root of, since point P coordinates are a1 b1 c1, then it will be what? It will be root of a1 square plus b1 square plus c1 square, then square root of OQ, nothing but a2 b2 c2. So a2 square plus b2 square plus c2 square. This will be the cosine angle. Now, what about angle? Very simple. Take cos inverse on both the sides. This is cosine angle. If I take cos inverse both the side, we will get cos inverse of a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square, and then again root of a2 square plus b2 square plus c2 square. And not taken mod here. The angle can be negative, and don't forget cosine theta is going to vary from where to where? 0 to pi. In the chapter vector we have discussed. So 0 to pi by 2 will be acute angle, and pi by 2 to pi will be obtuse. So 0 to pi by 2, the cosine value will be positive. So as soon as this is positive, nothing but, since cosine is equal to positive value, 0 to pi by 2, cosine will be always positive, nothing but it will be acute angle. If this value is negative, and we know in second quadrant, that is nothing but pi by 2 to pi, cosine will be negative, nothing but it will be obtuse angle. So with this we can also have an interpretation about acute as well as obtuse angle. Having this, one next point will be, before I go ahead now, further to analyze, one question might come here, that when I am talking about the angle between the two lines here, if you see very carefully, the line is passing to the origin. So one doubt will be there, sir, always every line need not pass through the origin. If the lines are not passing through the origin, then how are you going to find the angle between those two lines? Very simple it is. See, let us suppose I've got two lines here. One line is here. Okay. Let us suppose L1, L2 I have taken, so L3 there is, and one more line is there here, L4, and there is an angle theta here. I want to find the angle between this. So here I will take coordinate somewhere here like this. Okay. I think space is not sufficient. Far away. We'll take it somewhere here. Acha, fine. So it is somewhere above. Now, how are you going to find the angle between these two lines? Okay, listen carefully. What we are just going to do now, we are going to have the same logic. For this, the line should pass to the origin. So what we will do, we draw a line parallel to this, but passing to the origin. So this line passing to the origin, it is here. Is it making parallel? Yeah, fine. Yeah. Now let's click parallel. Yes. So I'll take this as L3 dash, and then this line, right? This one. Okay. Passing through the origin. Yes. Yeah. So both are going to pass through the origin. This is your L4 dash. So whatever the angle is, same angle here. So whether we are going to have a line passing to the origin or not, both will give this. Both can be used. I mean to say, whether line passes to the origin or not, same formula hold. Okay, for finding the angle. Next, here in this case, now I have not given you the equation of the line. I have given you direction ratio of the line. Direction ratio of the line L1 is A1 B1 C1, and direction ratio of the line L2 is A2 B2 C2. What if I have been given you equation of the line? So let us suppose that, again one more heading, angle between two lines. But in this case, equation of line is given to you, not direction ratio of the line. So equation of line is given. equation of lines are given. Now, since I'm talking about angle between two lines, so I should have two line equation. For a while, two lines equation. So line L1 is vector R is equal to vector A1 plus lambda times of vector B1, and the line L2 is given by vector R is equal to vector A2 plus mu vector B2. Don't forget both lambda and mu are any scalar but non-zero scalars, understood. Now I want to find the angle between the two lines, and here I have given the equation of the line in vector form. So again, see carefully, just a basic logic, listen carefully. So if at all I want to find angle between the two lines, see carefully, observe the things. Is it looking perpendicular? Oh, this will be slant far away. This is much better. So this is Z and this is X and this is the origin. Now see, I have got one line L1 and we have got one more line. Okay, it's looking parallel to y-axis. You may think as a particular case. I don't want to take as a particular case. So for a y, this is better. This is the line L2. Okay, now they are intersecting somewhere here, and I want to find this angle. Now see carefully. Geometry will do lot of job for us. We can understand things very easily by geometry. Now don't forget the concept of this line. This line's equation says that A1 is a point on the line, position vector of the point on the line, and vector B1 is a parallel vector to the line L1. So for this L1, okay, since I have used here capital, okay, I'll use small L1 here because I use small letter here. Okay, this is also small letter. Now see here, for line L1 we should have a parallel vector somewhere here. That is our vector B1. Is it looking parallel? Okay, now so fine. I think when I'm drawing this, I should stand opposite to the board only, then no, yeah, it will be, see this. Now it is. I think I should stand exactly opposite to the board when I'm drawing, only then it will be perfect. Yes. So you can see here line L1 and B1 both are parallel. Okay, I'm not in the figure, no problem. Now see this. Now coming to line L2, see carefully. Line L2, see, line L2 has got this other equation. This vector A2 stands for the position vector of the point to which the line passes, and B2 is a parallel vector. So that B2 parallel vector should be this. Now see carefully. This is your vector B2. Now coming to the angle between them. Can you see very carefully? Whatever the angle we have here, I repeat, angle between L1 and L2. Same angle is also formed here. Do you agree? It's a corresponding angle. Just see. One is here and one more is here. And since both are parallel, corresponding angles are what? Equal. So whatever the angle we have got here, same angle is there here also. So what I want to stress here is, even though the heading is angle between the two lines, there is no need to take the entire line. In place of finding angle between the two lines, you can find the angle between the two parallel vectors. Each of the vectors parallel to the given line. So B1 is parallel to L1 and B2 is parallel to L2. So the angle between the two lines will be cos theta is equal to, the angle is between vector B1, B2. So as I said, since the angle was between A and B, so it is dot divided by its magnitude. So here is the angle between B1 and B2. So it is dot product of B1, B2 divided by magnitude of B1 into magnitude of B2. Again, I am just giving a bracket. Next, if I take, so this will be our equation, means angle between the lines. If the equation of line is given in which form? Vector form. Here the equation of line is given which form? Vector form. Now let us suppose the equation of the line is given in Cartesian form. Which form? Cartesian form. So Cartesian equation of the line L1 is given by x minus x1 by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1, and the line L2 in Cartesian is given by x minus x2 by a2 is equal to y minus y2 by b2 is equal to z minus z2 by c2. This is the Cartesian equation of the line. Now when Cartesian equation of the line is given, now I want to find angle between them. So cosine angle, see, whatever we have given the explanation here, this equation also represents the same line. This is in Cartesian and this is a vector. So as we understood that angle between the two lines is also same as angle between their parallel vectors, and nothing but the direction ratio of the line. Don't forget that is in denominator. So the cosine theta will be dot product, see here b1 dot b2. This will be our vector b1. This denominator which is there, that will be our vector b1. Let us mention here. Vector b1 will be the denominator present here, provided x multiple, y multiple, z multiples are positive one. So vector b1 is here a1 I cap plus b1 j cap plus c1 k cap, and vector b2 will be this a2 b2 c2, the direction ratio of the second line. So vector b2 will have its that as a scalar components. Okay. Now see carefully. B1 dot B2. Come on. Perform dot product, multiply I with I, J with J, K with K. So from here A1 A2 plus B1 B2 plus C1 C2 whole divided by modulus of B1. So mod of this will be square root of a1 square plus b1 square plus c1 square. Then again square root of this, for this also a2 square plus b2 square plus c2 square. And if you just see, this is same as what we have got here. Means we here. Okay, if I just take cos inverse both sides, I'll get that also. Ultimately, to find angle between the two lines, direction ratios are required. Nothing else. First, make a note. I just want to have some discussion from here. Kindly make a note. Now, dear students, let us try to discuss some of these special case here. Before that, okay, let us suppose that in place of direction ratio, direction cosines are given. So let us go take from here all as note. Note number 1: if L1, M1, N1 and L2, M2 and N2 are direction cosines of the lines L1. Okay, to avoid confusion here. Okay, now here in the note I will just take as capital L. Okay, L1 and L2 respectively. I have just so in place of small L1 and small L2, I have taken as capital L1 and L2 to avoid confusion, because L1 and L2 are already used here for direction cosine. So our direction cosine of the lines respectively, then the cosine angle is given by, see carefully, in place of direction ratios, now we have got direction cosines. So the role of A1, B1, C1 and A2, B2, C2 is taken care by L1, M1, N1 here and L2, M2, N2. So we are going to have just substitute here. So it's a product now, L1, L2, L1, L2 plus M1, M2 plus N1, N2 divided by root of what will get, divided by what will get, root of L1 square plus M1 square plus N1 square. But it's what? 1. Relationship between direction cosine. What is that? L square plus M square plus N square is equal to 1. In place of L, M, N, we are adding L1, M1, N1 because we have got two direction cosine each for one line. So same no. If at all you have got any point x comma y comma z, if you have got more than one point, nothing but 2 points, then what you will do? X1, Y1, Z1. One more is what? One more point is what? X2, Y2, Z2. Same thing here also. That since we have got two direction cosines, because for each line we want one direction cosine, so we have given L1, M1, N1 and L2, M2, N2. So the reason remains same. And root of this. So again, what is that? L2 square plus M2 square plus N2 square is equal to what? 1. Root of 1 is what? 1 itself. Therefore, the cosine angle, if direction cosines are given, it's only this. No denominator, because it will be equal to what? 1. Next, let us suppose that the lines are perpendicular. The lines are perpendicular. Nothing but the angle between them is 90 degree. Put here theta is equal to 90. Cos 90 is 0. So I can cross multiply denominator to the left hand side. 0 into this denominator, when I cross multiply, will be 0. Only I'll get numerator, that is a1 a2 plus b1 b2 plus c1 c2 will be equal to 0. And this is vector form. Coming to Cartesian form, theta is equal to, this is, I repeat, this is Cartesian form. Coming to vector form, theta is equal to 90. Cos 90 is 0. Again cross multiply, then what will get? B1 dot B2 is equal to 0. Now it's left to you whether you want in vector form or Cartesian form. I have given both. Okay. Next, if lines are perpendicular, if lines are means to say parallel, perpendicular we have discussed, the lines are parallel. Recall in vector chapter, if lines are parallel, the direction ratio should be proportional. Same thing here also. The direction ratio should be proportional, and the direction ratios are A1, B1, C1 and A2, B2, C2. That should be proportional. So A1 by A2 should be equal to B1 by B2 should be equal to C1 by C2. Okay. So I have discussed all the concept on angle between the lines, whether it's passing to the origin, not passing to the origin, and if equation of lines are also given, how to tackle. So now we are ready for the problems. And if you see, if I know chapter vector algebra, 3D is easier. We can just say no, it's an application of three-dimensional geometry. We can take as application of chapter vector algebra. The way we have got application of derivative chapter, which is an application for chapter number 5, continuity and differentiability. Similarly, application of integrals, which is, I can say no, from chapter integrals. After we have learned integrals, what is the application of that? We are learning in the chapter application of integrals, chapter number 8. Correct? Similarly, this chapter is giving us an application of what? Chapter vector algebra. Kindly make a note. Dear students, having understood the concept on angle between the two lines, now time for problems. From model question paper number 1, we have got a 2-marker question. As you know, this we are solving model question paper issued by KSEAB for PUC, and it's a 2-marker question for the academic year 2025 to 2026. Question says find the angle between the pair of lines. Pair means what? Two. Pair of lines given by this. Lines are given here. Coming to solution. See, they are given Cartesian. That's what I gave in Cartesian vector form. Also in Cartesian form also. Equation of line and how to find the angle between them. Now, coming to Cartesian form. Don't forget, it is cos theta is equal to A1, A2 plus B1, B2 plus C1, C2 divided by square root of A1 square plus B1 square plus C1 square, then square root of A2 square plus B2 square plus C2 square. Fine. So don't forget x, y, z. If multiples are 1, then the denominators are direction ratio of the line. So A1, B1 is equal to 5, C1 is equal to 4, A2 is equal to 1, B2 is equal to 1 and C2 is equal to 2 are the direction ratio of the lines. Now let's substitute here. A1 is 3 and A2 is 1 here, plus B1 is 5, then into 1, then C1 is 4 into 2, whole divided by root of 3 square, plus B1 is 5 square, then 4 square. Just we are going for substitution. Then root of A2 1 square, plus again 1 square, then 2 square. Let's simplify this. 3 ones are 3, then 5 ones are 5, plus 4 twos are 8, divided by square root of 3 square 9, 5 square 25, then 4 square is 16, then root of this 1 square will be 1, 1 square will be 1, and 2 square will be 4. So 5, 6, 7, 8, 8 plus 8 will be 16, divided by 9 plus 16 is 25, 25 plus 25 will be 50. Then here 4 plus 1 plus 1 will be 6. Coming to 50 to same as 50, we can write as 25 into 2, and 6 we can write as 2 into 3, right? Let's complete it here. Now see carefully. Left hand side is cos theta, so cos theta is equal to 16 divided by root of 25 is 5, and see here 2 into 2 is 4, so root of 4 is 2. I repeat, see carefully, this is another root, this is also another root. Root 2 into root 2 will be root 2 the whole square, nothing but 2, then root 3 as it is. Let us give the reason. Root 2 into root 2 will be root of 4. What is root of 4? 2. Okay. Next, 2 ones are 2 eights are 2 eights are. So we will get theta is equal to cos inverse of 8 divided by 5 root 3. This will be the angle between the given lines. Cos inverse of 8 by 5 root 3. Now let us move on to model question paper number 3. Question says find the value of k. K is here and here also. So that these two lines are at right angle, nothing but the angle between them is 90 degree. What is the condition for two lines to be perpendicular in Cartesian form? I have given you this A1, A2 plus B1, B2 plus C1, C2 is equal to 0. This is condition for perpendicular. Condition for perpendicular of two lines. Now, see carefully the line equation. Again, you can see x, y, z multiples are 1. X multiple is also 1 here, y multiple also 1, and z multiple also 1. So just the denominator, the direction ratios we can take. So this is A1, this will be A2, B1, B2, C1, C2. Let's substitute. See, they didn't ask you to prove perpendicular. They have said if it is perpendicular, find the value of k. So I'm equating to 0 because it's already given that it's perpendicular. Let us suppose the question was prove it's perpendicular, then I have to take only left hand side. On simplification, I should get equal to 0. Now, A1 minus 3. Hope it's recording. A1 is minus 3. A2 is 3k. Then B1 is 2k. B2 is 1. C1 is 2. And C2 is minus 5. Simplify now. Minus 3 3s are 9k. Then plus 2k into 1 will be 2k. Plus into minus 2 5s are 10. Minus 9k plus 2k will be minus 7k. On transpose we will get plus 10. And on cross multiplication, because I want k value, therefore k value will be 10 divided by minus 7. What is plus by minus? So k is equal to minus 10 by 7. Therefore the value of k is minus 10 by 7. It means for this value the lines are perpendicular. It also means that all completed here. One note I want you to understand that, let us suppose for 1 marker the question is for what values the lines are not perpendicular. So note for k belonging to from all the set of real number, if I remove minus 10 by 7, the above lines, nothing but these two lines, the above lines are not perpendicular. Who knows? So 1 mark. For which all values the lines are not perpendicular, remove that value for which we got perpendicular. Since we are dealing with set of real numbers, from R remove this real number. Okay, fine. Kindly make a note. Dear students, let us move on to next concept. See, coming to 2 dimension, the behavior of pair of lines can be, see, the line can intersect, the pair of line can be parallel, and the last case can be the line can be coincident. These are the only 3 cases when we talk about a plane, nothing but 2 dimension. But as soon we go for 3 dimension, we have got one more scenario excluding this. Line can, even in 3D also, line can be intersecting, parallel and coincident. But one more extra point will be the line can be skew lines. Now what is the skew lines? These are those lines, pair of lines, which are neither intersecting nor parallel. See, let's take one example here to make it clear. If I just try to take a cube, see carefully. Okay, I'm taking one cube to make the things clear. See carefully. Yeah. Now let us name this A, B, C, D, E, F, G and H here. Now the line. One line, see, can be in this phase DC, AB. One line is here. Okay. And one more line can be somewhere here. These 2 lines are not lying on the same plane. This line DB is lying on the plane ABCD, whereas this line EC is lying on the top, the floor. If I just talk about itself as a room, no. So it is one on the wall. In this, see this. If I talk this to be a room, then ABCD is a wall, whereas DCFE is a roof. Roof, correct? So one line is there on this wall. This entire wall is there. No, one line is here, and one more line is there on the roof. So these are those lines which are not lying on the same plane. This we call skew lines. So any line which is neither parallel nor intersecting. Now let us try to find the shortest distance between the 2 skew lines. We'll take a problem on that. Kindly make a note. Okay. Dear students, now let us proceed with the derivation of shortest distance between 2 skew lines. Between 2 skew lines. Kindly focus, pay attention. This is not a 3 marker or 5 marker question. As I said, no, I want to go for each and every concept. Surely problems will be from model paper issued by KSEAB, but concept, if I take any chapter, each and every concept should be discussed. Okay, that's the motive. Now, I've got 2 lines, L1 and L2, and these are skew lines. What are skew lines? These are those lines which are neither intersecting nor parallel. Just see this. If I extend this direction, no, it's looking like it's going to be parallel. But when I extend this direction, no, it's looking like it is looking like it is going to intersect. Okay. Now, see carefully. As I said previously, I just took one example where one line was on the roof, another was on the wall, correct now? Now here, shortest distance will be always a perpendicular distance. So I have taken the distance between L1 and L2 as PQ, and this will be the shortest distance D, and here it is perpendicular. Here also perpendicular, but many will have an objection. Sir, we are agreeing this is perpendicular, but this is nowhere looking as perpendicular. For that, understand that we are trying to make the things clear. We are trying to understand 3D in 2D frame. Both is 2 dimension. We have got only x-axis and y-axis. So for this, let us try to come out from the word approach and let us try to understand practically. Okay, hand is visible now on this side. Fine. Understand that. Let us suppose this is your ground. One line is here, and I could have taken forever. I'll take one pen as well. See this carefully. Correct. So here, this is the ground, and there's a line here. Now there is a roof, and the roof is this hand roof. Okay, so we have one more line. Okay, one more line. This is the line you can see, correct? Now I want to find the shortest distance. The shortest distance. Now for a while, you assume L1 to be this marker, the line, and L2 is this line. Okay, which is there on the roof. This is the roof, so line is here. Okay, now I want to find the shortest distance. So this line PQ is the pen. Now see carefully. See carefully now. What is the angle between both the marker and the, I can see myself on camera. Yes, it's visible. So you can see the angle between both the markers with respect to this pen is what? 90 degree. That's what I wrote, 90 degree. Then you may ask, sir, why you have drawn with slant, why you are not drawing parallel? If I draw parallel like this, is a parallel line. I am talking about skew line, which is neither parallel nor intersecting. Okay, I have in diagram also. Yeah, even camera I can see it's not looking parallel. Okay, fine. I have this logic is clear why it is perpendicular. Okay, actually I used to enjoy this chapter a lot when before edition of syllabus, where we have planes, equation of planes in third exercise completely removed. Then we can see the real application of mathematics. Okay, fine. Come back. So now here, the distance PQ is D, but as soon as I give an arrow mark, it becomes a vector. But D is a scalar. So since PQ I have got, this is the shortest distance D, and I want to find this distance D. But since I've given an arrow mark, it becomes a vector. So it is, I'm going to give a vector to be a unit vector. One question will come, why you are giving unit vector, sir? Why not ordinary vector? Reason is this, see this carefully. If I take D n cap, and if I take modulus, so D mod, and then modulus of n cap. Since n cap is a unit vector, the magnitude is 1. 1 into mod D will be D itself. Thus the reason we are taking unit vector. Let us suppose that we have not taken unit vector, some other vector we have taken like vector n. I have to remember, if I just give this symbol arrow, it is a usual vector, it need not be a unit vector. Now you see modulus of D, then modulus of n. Since n is not a unit vector, let us suppose n value, the length of this n is 2, then I'll get 2 times of D, which is not the actual distance. Thus the reason we are always going to take a unit vector, will not take any arbitrary vector. Okay, I hope this point is clear. And now if you focus on n cap, it's not only a unit vector. See this carefully, it is a vector perpendicular to L1 as well as L2. And let us write the equation of this line. See carefully. The equation of the first line L1. This line L1 is passing through a point S whose position vector is A1 and is parallel to vector B1. Don't forget the concept. The derivation which I did, the equation of a line passing to a point and parallel to a given vector. So L1 will be vector R is equal to vector A1 plus lambda times of vector B1. Whereas L2 is a line passing to a point T whose position vector is A2 and it is parallel to a vector B2. A little bit bigger, B2. So the equation of the line L2 will be vector R is equal to vector A2 plus mu vector B2. Don't forget the parallel vector will always have a scalar, any real number. Okay, lambda and mu are any real number. Surely not 0. Okay, fine. Having understood this, now actually, as I said, n cap is a unit vector what parallel to the line L1 and L2. Don't forget, let's extend this vector still more here, and this also still more. See carefully. This n cap is a unit vector perpendicular to L1 and L2. But since L1 is parallel to B1 and L2 is parallel to B2, is it not even this vector is perpendicular to what? B1 and B2. So I can say that n cap is a unit vector perpendicular to both vector B1 and B2. Recall chapter vector algebra. Recording no? Chapter vector algebra, that a vector perpendicular to A and B is given by its cross product. Similarly, a vector perpendicular to B1 and B2 is given by its cross product. So B1 cross B2. But since it's a unit vector, divide by its magnitude. And this is equal to n cap. Okay, so PQ is the distance to be found, equation number 1. Then vector PQ is dn cap. This will be our equation number 2. Okay. And n cap, we have found the expression. All are from vector algebra. Now, how are we going to find this length? If I just, now this length is given by the projection of the vector ST on PQ. So if I just give a torch here to have a clarity, if so torch is here, so the shadow of this will be falling on here, correct? No, so projection, so PQ length is given by the projection of this. Recall what was the formula for projection? Projection of AB on the line was AB into cos theta. So projection of ST on this PQ will be ST into cosine theta. But what is cosine? Now theta, what is theta now? Angle between this ST and PQ. See, if I just extend somewhere, they are going to make an angle theta here. Okay. So now coming to cosine theta, what is cos theta? If vector A and B makes an angle theta here, then cos theta is given by dot product between A and B divided by magnitude of A into magnitude of B. Correct? No? So here cos theta is actually angle between ST and PQ. As you can see now, if I extend, the angle is right here. So theta is angle between ST and PQ. So I can write ST as it is in place of cos theta. Since theta is angle between A and B, dot of those two vectors divided by its magnitude. Since theta is angle between PQ and ST, so it will be dot of vector PQ with ST divided by magnitude of PQ, magnitude of ST. Very clearly you can see that ST will get cancelled, the length. Remaining is PQ dot ST vector divided by magnitude of PQ. But what is PQ? See, if I talk about length, it is D. If I talk about the vector, it's dn cap. So see carefully. Let us write the left hand side as it is. PQ. Now PQ is what? D. Length of the PQ, D. Okay. This is Q minded. Next, again PQ vector dn cap. n cap dot st. What is st? St is a vector joining 2 points. So from vector algebra chapter, vector a b is ob minus os. So vector st will be ot minus os divided by, again mod of pq is d. And I mentioned that what is vector AB, vector joining 2 points. In this, first letter is A, second is B, initial point is A, terminal point is B. So it is what? OB minus OA. Next, can you see very clearly? D will get cancelled here. So remaining is n cap. What is n cap? B1 cross B2 divided by modulus of B1 cross B2. Okay, so in place of n cap, I have substitute this value. Let I give a bracket dot OT minus OS. OT is a position vector of the point T and OS is position vector of the point S. Come back to diagram. Position vector of the point S is A1. What is position vector? Any vector whose initial point is origin. We have not shown the origin here and joined because already diagram two many things are there. It's understood that as soon as I got any point, always those point can be joined from the origin. Hence, those are initial point. Okay. So OT and OS. So position vector of the point T is A2 and vector A2 and position vector of the point S is vector A1. I repeat, position vector of the point T is vector A2. Position vector of the point S is vector A1. So in place of OT, it is vector A2 minus for S. OS will be vector A1 and left hand side as it is. And since we are dealing with distance cannot be negative. But here you see dot product between, see, difference of these two vectors is again a vector. Cross product is again a vector. But when I take dot product between these two vectors, the output will be what? Scalar quantity. Scalar can be negative also, positive also. So we are taking modulus here so that even if I get negative value, we are going to take only positive because distance cannot be negative. And this is the formula to find distance between the two skew lines. And if you see the formula, when we are going to solve the problem, we are going to again recall difference of two vectors, one operation, then cross product, second operation, dot product, third operation, modulus, 4 operations. So totally 4 operations we are going to involve with this. This is not any derivation for 5 marker, not for 3. Just I thought let you know the things. Okay, each and everything should be understood than just giving the formulas. Kindly make a note of this. Okay. Dear students, now let us move on to the problem on distance between two skew lines. This is from model question paper number 3. And as usual, you know that it is from KSEAB model paper. And for the academic year 2025-2026. I'll be also giving you the Cartesian form. Let you have that information. So, questions is find the distance between lines L1 and L2 whose vector equations are given. We also have got parallel lines also, we will take that. But here, the most important thing is, since the lines are not parallel nor intersecting, therefore, the direction ratios of both the lines should be different. So, you can see direction ratio, as we know, is given by, for any line, the direction ratio is given by the vector that is scalar multiple, that has got a scalar multiple. And you can see both this vector direction ratios are proportional. 2 by 3, minus 1 by minus 5 and 1 by 2 all are not equal. So how to know the given line is not parallel? It's a skew line. The direction ratio should be not to proportional. You can see here 2 by 3 is not equal to minus 1 by minus 5, not equal to half. When I take parallel lines, you will see that this two will be proportional. Now, coming to this, don't forget the equation of the line when we went for derivation. It was vector R is equal to vector A1 plus lambda vector B1. And the second line L2 was vector R is equal to vector A2 plus mu vector B2. So in place of vector A1, we have this. So I can write vector A1 is I cap plus J cap. we have only I cap plus j cap, there is no k component, it means its multiple is 0. So I cap plus j cap, let's write in next line better. So I am going to have vector a1 is equal to I cap plus j cap plus 0 k cap. So why we are bothered about k cap? Because you can see k cap is present in remaining vectors. So we should know that k cap is not 0, its multiple is 0. I cap, j cap, k cap are unit vectors acting along positive direction of x-axis, y-axis and z-axis. We already understood in chapter vector algebra. Now, see, in place of vector a1, we have this. Next, in place of vector b1, we have this vector. So vector b1 is equal to 2I cap minus j cap plus k cap. Next, coming to second line, second line equation, vector a2 is here. So vector a2 is equal to 2 minus 1 and plus 1, 2I cap plus j cap minus k cap. And vector b2 is equal to, scalar is mu here, vector b2 is here. So 3I cap minus 5j cap plus 2k cap. Let us cross check have we written correctly, because a single error, the entire point will be wrong. So what was the formula we derived? Distance is modulus of b1 cross b2 dot of difference of the vector a2 minus a1 divided by modulus of b1 cross b2. So this is our equation number 1. One by one we are going to find all of this. First, let us try to find a2 minus a1. So vector a2 minus vector a1. So I have to subtract both the vectors. Vector a2, as you can see here, and vector a1 is here. So 2, 1 minus 1. So vector a2, 2, 1 minus 1. Then minus of vector a1 is here. So it is I cap plus j cap plus 0 k cap. Be careful. Here we have got different negative sign for a1 vector. So I have given a bracket. Many students will not give a bracket. When you are not giving a bracket, what's the meaning? You are multiplying negative only for I component, not for j, not for k component. So bracket, the basic things are so important here. Now let's simplify. 2I cap plus j cap minus k cap, minus plus is minus, minus plus is minus, minus plus is minus. So here 2 minus 1 will be 1. How to add or subtract two vectors? I with I, j with j, and k with k. We have to add or subtract depending on the sign, same or different. Next you see. So 2 minus 1 is 1, 1I cap. J multiple is 1, and here it is minus 1. So plus 1 minus 1 will be 0. So 0 j cap. Then minus k cap and minus 0 k cap will be minus k cap itself. Nothing but minus 1 minus 0 is minus 1 itself. So this is our vector a2 minus vector a1. We have got vector a2 minus vector a1. Next, what we want? We want cross product of b1 and b2. Find the cross product. b1 cross b2. Recall chapter vector algebra. Cross product is given by determinant, where the first row is I cap, j cap, k cap. Second row is scalar component of b1. What is b1 scalar component? 2 minus 1, 1. 2 minus 1, 1. Recall what do you mean by scalar component? Multiple of ijk. Okay, in the vector. Now you see here. Next I want third row. Third row is scalar component of vector b2. Vector b2 is here. Scalar components are 3 minus 5, 2. 3 minus 5, 2. Now plus minus plus. Now let us expand this. I cap of, leave the row and column where I cap is present. I cap is present in first row and first column. So remaining will be minus 1, 1, minus 5, 2. Minus 1, 1, minus 5, 2. Then minus plus is minus j cap. Leave the first row and second column. You get 2, 1, 3, 2. 2, 1, 3, 2. Then plus k cap. Leave the first row and third column. 2 minus 1, 3 minus 5. Now change the sign, means give the signs. Not changing, we have to multiply. Yeah. Now see carefully, cross multiplication now. Minus plus is minus. Minus 1 into 2 will be minus 2. then minus into minus is plus, 5 ones are 5, minus j cap of, again cross multiply, plus 2 twos are 4, minus 1 into 3 is minus 3, plus k cap of, again cross multiply, plus into minus minus, 2 5s are 10, then again cross multiply, minus to minus plus, 1 into 3 is 3, minus 2 plus 5 will be 3, 1 minus 3, sorry, 4 minus 3 will be 1, 1 into minus j cap will be minus j cap, minus 10 plus 3 will be minus 7, minus into plus will be minus 7 k cap. So this will be vector b1 cross b2. We have got b1 cross b2 as well. See, we also want dot product and magnitude. First, let's find the magnitude. So b1 cross b2 magnitude square root of, yeah, I multiple 3, so 3 square, plus j multiple is minus 1, so minus 1 whole square, plus k multiple is minus 7, so minus 7 the whole square. This will give you root of 3 square is 9, minus 1 whole square is 1, 7 square is 49, so 9 plus 1 is 10, 10 plus 49 will be root 59. Left hand side b1 cross b2. Okay, this also done. Next we want b1 cross b2 dot with a2 minus a1. Let us find that. b1 cross b2 taking dot with vector a2 minus vector a1. b1 cross b2 we have got here. Substitute 3i cap minus j cap minus 7k cap dot with a2 minus a1 where we have got, yeah, here it is. So I cap plus 0 j cap minus k cap. See, whatever the steps I'm doing, it just, this formula is making us do the job. Formula said find difference of a2 and a1. Formula said find the cross product. Formula said find the magnitude. Now formula is saying take the dot product. Everything formula is instructing us. So memorizing the formula is very important for skew lines, distance, shortest distance. 3 mark short question. Now multiple of I is 3 and here it is 1. So how to take dot product? Multiply I with I, j with j and k with k, scalar components, and then sum them up, simplify them up. Now, so 3 into, yeah, 1 here. Next minus I, j multiple is minus 1 and here it is 0. So minus 1 into 0. Next k multiple is minus 7 into minus 1. So minus 7 into minus 1. If we simplify this, we are going to have 3 ones are 3, 3 ones are 3, minus 1 to 0 is 0, minus to minus plus, 7 ones are 7, 7 plus 3 is 10. So we are getting here b1 cross b2 dot a2 minus a1. Now just we have to substitute. See, b1 cross b2 I will take as equation number 2, that is this part, and its entire numerator is here, equation number 3. So put equation number 2 and 3 back in equation number 1. When we substitute in equation number 1, that is this, d is equal to, be careful, the numerator part is there in equation number 3, that is 10, divided by denominator, that is b1 cross b2 magnitude, is root 59. Let us suppose now denominator should not be an irrational number, so we can multiply and divide by its conjugate. So 10, so root 59 divided by, here also root 59, we are multiplying root 59 and dividing by root 59. So we will get d is equal to 10 root 59 divided by root 59 into root 59 will be only 59, since and length units we will mention. So this is the shortest distance between these two skew lines. Okay. Just calculation based, nothing else. Kindly make a note. And it's a 3-marker question. Just one point here. Many students will be wondering that we have seen the formula a2 minus a1 dot b1 cross b2. Denominator, there is no problem. Dear students, dot product is commutative. So I attend this one first and then the second. A dot B is same as B dot A in vectors. Vector A dot B is same as vector B dot A. Okay, kindly make a note. Dear students, I have given one assignment problem from exercise 11.2. Find the distance between those two lines. If you want, you can convert this one to vector form and then apply the same formula which I have already derived and we have discussed on problem. Or we can now also have a formula in Cartesian form. Let I give it. Who knows, for 1 marker, no assertion is in type question if they ask, you should be aware of. So I'll just give the formula. Working out should be done by you. See carefully. So shortest distance. See, whether I say shortest distance or only distance, both are same. Whenever we want to find the distance, we want what? Shortest distance, minimum distance. Okay. So shortest distance between the two skew lines. Which are the skew lines? L1 is x minus x1 by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1, and one more line L2 is x minus x2 by a2 is equal to y minus y2 by b2 is equal to z minus z2 by c2. So I have got two lines in Cartesian form. Then the shortest distance is given by d is equal to determinant of x2 minus x1, y2 minus y1, z2 minus z1. First row will be difference of the point. How to find the point? Very simple. So what are this x1, y1, z1 and x2, y2, z2? As we discussed during the derivation of the line, that those are there in the numerator. So here, just change the sign. We are going to have x1, y1, z1. This is the point through which the line L1 is passing. Similarly, in the second line L2, you can see here x2, y2, z2. Change the sign. Here the sign is negative, negative, negative. Change the sign. So I'll get x2, y2, z2. Okay, that's what you can see the difference of these 2 points. Whereas the second row will be the direction ratio of the line L1. That is in denominator. That is A1, B1, C1. So A1, B1, C1. Whereas the third row will be the direction ratio of the second line A2, B2, C2. Whole divided by square root of A1 B2 minus A2 B1 square plus B1 C2 minus B2 C1 square plus C1 A2 minus C2 A1 square. And determinant, as you know, can be negative also, so we'll take a modulus here for the entire. So this will be in Cartesian form. See, let us try to understand how to remember. First row will be difference of the point, second row will be direction ratio of the first line, third row will be direction ratio of the second line of the determinant. Whereas coming to denominator, yes, many students will feel difficult to memorize. Not difficult, just see carefully. Then I write this very clearly, it's a square here. See, just see carefully, just see. Play with the index. See here, AB, again AB, correct? First see the pattern. All have got square, 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 and it is sum of the term, and each of the term in the bracket is difference, difference, difference. So all have got square. Each term inside the bracket is product of difference of two terms. Now you see AB, AB, BC, BC, CA, CA. Let's see 1, 2, 2, 1, 1, 2, 2, 1, 1, 2, 2, 1. That's it. Now coming to this, what is the point on the line? Just in the sign, it is plus, plus, plus 1. So change to minus 1, minus 1, minus 1. And for this, all are negative. So change the sign should be 3 plus 5 plus 7. And this will be our A1, B1, C1, the direction ratio of the first line. And this will be the direction ratio of the second line, A2, B2, and C2. So from here, you are going to complete as an assignment. Kindly make a note. And one more thing before I forget. See, from here, one note I want you to have. What is the condition for a line to be coplanar? First, what do you mean by coplanar or coplanarity of two lines? See, what do you mean by coplanar? First, understand this. Let us have some space here. See, as we discussed in 3 dimensions, the line, skew lines did not lie on the same plane. So coplanarity of two lines. When do we say two lines are coplanar? Whenever two lines lie on the same plane, then we say it is coplanar. So whenever, definition first, for coplanar, whenever two lines lie on the same plane. Now the question mark is, what is the condition for two lines to be coplanar? So condition for two lines to be coplanar. Under what condition they will lie on the same plane? Very simple logic. See this carefully. As I discussed, coming to skew line distance between shortest distance, I just said assume that this is our floor and this is the roof and this is one line L1, the other line is this, correct? And the distance between them, let us just take the pen again. So the distance between this two line, this is first line and this is the second line, yeah, visible, second line, correct? So the distance between them was this, visible, no? Yeah, correct. Now this distance is given by this formula, d is equal to this entire. Now as soon as say both the lines are lying on the same plane, that we call coplanar. Okay, and I'm trying to go for a condition for two lines to be coplanar, nothing but lying on the same plane. Just see, as soon as I say that this line in place of here is lying on the same plane, just see carefully, it's lying on the same plane, this distance whatever is there, d, should come to 0, because now both are lying on the same plane. As soon as I say both are lying on the same plane, the line can be parallel or it can be coincident or it can be intersecting, but in our case intersecting and parallel. Okay, so as soon this line is on the same plane, the distance is 0, nothing but d is 0. As soon d is 0, this denominator, this entire thing, you can cross multiply, and as soon as I cross multiply, we get the condition for coplanarity, and that condition is determinant of, this determinant should be equal to 0, because when this is 0, cross multiply this, 0 into this will be 0, so I'll get determinant of x2 minus x1, y2 minus y1, z2 minus z1 is equal to 0. Second row, a1, b1, c1. Third row, a2, b2, c2. So this will be the condition for coplanarity, nothing but condition for the line to lie on the same plane. Kindly make a note. Dear students, okay, dear students, now let us move on to the next concept, that is shortest distance between two parallel lines. This is your last concept. Let us try to derive the expression as well. Again, it's not for a 5 month, but again, as I said, students should know how they have got the result. See, you can see very clearly this line L2 and L1 both are parallel. L1 is passing through a point S whose position vector is A1 and it is parallel to a vector B. So the equation of the line L1 will be vector R is equal to, since it passes through a point S whose position vector is A1, so it is A1 plus lambda times of, since the line L1 is parallel to the vector B, so vector B here. Whereas coming to second line L2, this line L2 is passing to the point P whose position vector is A2, vector A2. Now since line L2 and L1 are parallel, parallel lines, okay, L2 and L1 are parallel and L1 is parallel to vector B. So I can also say that vector B is also parallel to L2. So the equation of the second line will be vector R is equal to vector A2 plus mu times of vector B. Coming to skew lines, we had just two different vectors B1 and B2 because L1 and L2 were not parallel lines. Don't forget that. And L1 was parallel to the vector B1 and L2 was parallel to vector B2. So we had B1 and B2 in that case. Now here it is not so. And this is what you're going to be seeing when you're going to solve the problem on parallel lines and skew lines, whether this vector are proportional or equal. Equal here, then it's a parallel line, or proportional. If it is not proportional, then it is skew lines. Vector B's are not proportional, then it is skew lines. And those are always multiple of a scalar lambda and mu. Lambda and mu it can be, or it can be some other number. And don't forget, both lambda and mu are real number. To be specific, they are non-zero real number. Okay. Now having understood this, now let's go for small concession here. This is angle theta here. If I just extend here, again this angle is also at theta. Why? Corresponding angles are same. Since vector B is parallel to line L1, so whatever the angle we have got, same angle here. School this concept, no? Whenever two lines are parallel, then this corresponding angles are what equal. If this is alpha, this is also what alpha. Now having this, and next, okay. See, TP, I'll take here TP, and here this is the distance which you have to find. And if I give an arrow mark, it becomes a vector. So I'll give d n cap. Same reason why I'm taking n cap. What I gave there. If I take the modulus, n cap will be 1 because unit vector, and 1 into d is d. And again, this is also perpendicular. This is also perpendicular. We want the shortest distance, and shortest distance is, I repeat, the shortest distance is always a perpendicular distance. Okay. So now let's write one by one. So first vector TP. If I take the modulus, it is only d, and if I talk about the vector TP, it is d n cap. Okay, again n cap is a unit vector perpendicular to both the lines, perpendicular to both the lines. Which are those? L1 and L2. Okay. Now having this. Now recall the cross product. What is A cross B? It is magnitude of first vector, then second vector into sine of the angle between them into n cap. So there is a vector A here. There is a vector B here. And there is an angle theta. So here there is an angle theta, and this is an angle between here B and ST. Vector B and ST. So let us take the cross product of that. So vector B cross vector ST is equal to whichever is the magnitude of that. So magnitude of vector B into magnitude of vector ST into sine theta into n cap. I have till here clear. Now we have got trigonometric function sine. We want to remove it. Now you see a right angle triangle here. So I'll take this as equation number 1 here. This I will take as 2, equation number 2. This we will regard as 3. So see carefully, in right angle triangle, which is that STP. Okay, this is our arrow mark here also. Okay, so STP. What will be sine theta? Don't forget, sine is a scalar quantity. So when I'm going to write a sine theta, it is opposite by hypotenuse. Opposite by hypotenuse. So it is TP vector but divided by ST. Many students will just think, no, this is enough. No, this is a scalar. This should be also a scalar. So take a mod here, and I am going to substitute in equation number 3. Equation number 3 is this. Now whatever equation number 3 will result, it will be vector B cross ST is equal to modulus of vector B into modulus of vector ST. In place of sine theta, we have got modulus of TP divided by modulus of ST into n cap. Without any trouble, we can see modulus of ST will get cancelled. Now remaining is vector B cross vector ST is equal to magnitude of B into mod of vector TP into n cap. Again, what is ST? ST is a vector joining 2 points, that is S and T. So recalling vector joining 2 points concept is now here. S is the first letter, T is the second letter. So it is vector OT minus OS is equal to modulus of B. What is TP? TP modulus D from equation number 1 into n cap. How I got from equation number 1. Now I want only what? D. Now see, I want length. Before that, let's write one more line. Vector B cross OT. Position vector of the point T is A2 vector. Position vector of the point S is A1 vector. So OT is A2 vector and OS is A1 vector. Okay, is equal to modulus of B into D n cap. If you see both the side, that will be left hand side or right hand side, we have vector. Cross product between the two vectors again a vector quantity, and you can see n cap is again a vector quantity. Don't forget, we want length D, the length D we want. So what we'll do, take modulus both the sides, and again here position vector of T and S we have taken as A2 and A1. Again you may be thinking, where is origin? As far as I said in skew lines, things, so many things are there. They are not taking origin and join. It's understood. Every point can be joined from the origin. Okay, this we have discussed in position vector concept of the chapter vector algebra. Okay, so now just see this carefully. So taking magnitude on both the sides. Taking magnitude on both the sides. Then what we are going to get? See carefully. Modulus of vector B cross vector A2 minus vector A1 is equal to mod of vector B, then D, then mod of n cap. This is to mind it. Don't forget, modulus of n cap is 1 because it's a unit vector. So this part will be what? What is it visible in camera? I think it's very right most. Nothing wrong. I'm not sure that it will be visible for you. So I'll do one thing. I'll just start from here. So again, I'm just repeating. I'm taking mod on both the sides. When I'm taking mod on both the sides, magnitude of B cross A2 minus vector A2 minus A1 is equal to magnitude of B, then D, magnitude of n cap. Okay, so magnitude of n cap is 1, as mod of n cap is 1 here. So the remaining will be modulus of B cross A2 minus A1 is equal to mod B into D. Don't forget, you want only D, the distance between the two parallel lines. So cross multiply mod B, then we will get, therefore D is equal to modulus of vector B cross A2 minus A1 divided by modulus of B. So this will be the expression for finding the distance between two parallel lines. If you just try to see this formula, if you compare with the skew lines, for skew lines, okay, this is completed, okay. I'm just trying you to understand the difference. Skew lines, we got D is equal to, it was B1 cross B2, then dot A2 minus A1 divided by modulus of B1 cross B2. Here we had two vector B's because lines were not parallel. B1 was parallel to line L1 and B2 was parallel to the line L2. So you can see, since we had the two lines to be parallel, as you can see here, only one vector B was sufficient to be parallel for both the lines. That's the reason we're not going to have two vector B's. So you should be very much careful while using the formula. As I said, for skew lines, direction ratios are not proportional of the vector B1 and B2. Whereas for parallel line, it will be proportional. Sorry, it will be proportional or it will be equal. Let us take a problem. That will be our last problem of this chapter. Kindly make a note. Dear students, now we are with the last problem from this chapter, and it is from model question paper number 2, a 3-marker question. Question says find the distance between the lines. They have not said parallel lines or skew lines. Similarly, after completing the derivation of skew lines, when I went for the problem, there also they have just mentioned find the distance between the lines. Whether it is parallel line or skew line, it is not specified. There, the vector which is multiple of lambda and mu, I took those vectors, and there the direction ratio were not proportional. As you can see here, it is proportional 2 by 2, then 3 by 3, and 6 by 6. It's equal to 2 by 2, 3 by 3, 6 by 6 equal to 1. Nothing but they are proportional. Hence, these lines are what? Parallel. Now, since the lines are parallel, we have to use the formula of distance between two parallel lines. So D is equal to vector B cross A2 minus A1 divided by magnitude of B. I repeat, D is equal to B cross A2 minus A1 divided by magnitude of B. Don't forget that this is your vector A1 and this is your vector B, and this entire thing is your vector A2. Let us try to get one by one. First, I want difference between vector A2 and vector A1. So A2 minus A1. Vector A2, 3, 3 minus 5. Substitute here. 3i cap plus 3j cap minus 5k cap minus of vector A1, 1, 2 minus 4. So I cap plus 2j cap minus 4k cap. So formula again is making us to solve. First it says find the difference, then take the cross product between vector B and this, and then take the magnitude of vector B. So let's proceed. 3i cap plus 3j cap minus 5k cap, minus into plus is minus, minus to plus is minus, minus minus is plus 4k cap. So now we can add 3i cap minus I cap will be 2i cap. Then 3j cap minus 2j cap will be plus j cap, minus 5k cap minus 5k cap, and plus 4k cap will be minus k cap. This is vector A2 minus vector A1. Next what? We should take cross with vector B. Fine. Vector B cross vector A2 2 minus a1 is equal to, how to take cross product? We have to find determinant of the first row is unit vector I cap, j cap and k cap. Second row is scalar component of the first vector b. What is the scalar component? Don't forget it's a vector b. So 2, 3 and 6. So 2, 3 and 6. A2 and second, the third row will be scalar component of the second vector a2 minus a1, that is 2, 1 minus 1. 2, 1 minus 1. Now plus minus plus sign is allotted. Now plus I cap. Leave the first row and the first column where I cap is present. Remaining is what? 3, 6, 1 minus 1. Then minus j cap. Leave the first row and second column. 2, 6, 2 minus 1. Then plus k cap. Leave the first row and the third column. 2, 3, 2, 1. Again plus minus plus minus plus minus. I cap of multiplying the diagonal element, plus into minus minus, 3 into minus 1 is plus into minus minus, 3 ones are 3, again non-diagonal, plus into minus minus, 1 into 6 is 6, minus j cap of, again multiplying this, plus into minus minus, 2 ones are 2, plus into minus minus, 2 6 are 12, then plus k cap of, again cross multiplying here, 2 into 1 is 2, minus 3 into 6 is minus 6. Simplify now. Minus 3 and minus 6 will be minus 9. Minus 2 and minus 2 will be minus 14. Minus 2 minus will be plus 14 j cap. 2 minus 6 will be minus 4. Minus 2 plus will be minus 4 k cap. And here we have got vector b cross vector a2 minus a1. So we have got the cross product. Now see the formula. We have to take magnitude for both. So find the magnitude of this. Magnitude of b cross a2 minus a1 will be square root of minus 9 square plus 14 square plus minus 4 square. Minus 9 square is 81 plus 14 square will be 196 and plus 4 minus 4 square will be 16. Add this. So 196, then 16, then 81, 6, 6, 12, 13, border 1, 10, 18, 19, 293. So this value is square root of 293. So modulus of vector b cross a2 minus a1. Next what? I'll take this as equation number 1. So I've got this, so I'll take this as equation number 2. Next, I want modulus of b. What is vector b? As you can see, vector b is 2, 3 and 6. 2i cap plus 3j cap plus 6k cap. Find the magnitude of this. It is root of sum of the square of the scalar components. So 2 square plus 3 square plus 6 square. This will give us 2 square is 4, 3 square is 9, 6 square is 36. So this will be root of 49. Root of 49 is 7. This we will take as equation number 3. So put 2 and 3 back in 1. When we substitute 2 and 3 back in 1, we are going to have d is equal to the numerator value. We have got root of 293 divided by mod of b, we got 7 units. So this is the shortest distance between the given two parallel lines. Kindly make a note. Yeah, dear students, we have completed all the concepts and the problems of this chapter, that is three-dimensional geometry. But I would like to just discuss the different ways of writing equation of coordinate axis, which can be for 1 mark, and previously it has been asked also. First, already at the beginning of the class, after while discussing direction cosine, I have discussed the direction cosines of all the three coordinate axes, x, y, and z axis. So direction cosines of coordinate axis. First one, if I only talk about x-axis, the direction cosine of x-axis is, see, I'm writing as 1. So it means the heading is given direction cosine of coordinate axis. That is, the first one is x-axis is plus or minus 1 comma 0 comma 0. Second one is for y-axis. The direction cosine is 0 comma plus or minus 1 comma 0. Third point, that is z-axis, and it is 0 comma 0 comma plus or minus 1. Fourth one, if I talk about positive x-axis, then the direction cosine of positive x-axis is plus 1 comma 0 comma 0. For all I am writing direction cosines, okay. Then positive y-axis is 0 comma plus 1 comma 0. This already we have discussed at the beginning. Again I am rewriting before I write equation of all the coordinate axes, as we need all this. And for z-axis, only 0 0 1 can be written, plus 1 I am writing for all the three, so that it's understood how it is positive number. Okay, coming to seventh, negative x-axis direction cosine is minus 1 comma 0 comma 0. Eighth one, negative y-axis is 0 comma minus 1 comma 0. And lastly, negative z-axis is 0 comma 0 comma minus 1. Okay. Now let us try to understand the equation of all this. Okay. Now for that, first recall what is the equation of line in vector form. So equation of line in vector form. So what is the equation of the line in vector form? It is given as vector r is equal to vector a plus lambda times of vector b, where vector a represents a point. It's a position vector of a point through which the line is passing, and vector b is a parallel vector. Now if I talk about the diagram, in terms of diagram, yeah, this is best, always take the diagram. Now see here, this is x-axis, y-axis and z-axis. Whatever I'm addressing is very, very important for 1 mark. Anyone can be asked, and if you see the previous year question paper, there also they have asked direction cosines, even equation of the coordinate axis as well. Okay, fine. Now see this carefully. See, for this to be written, I want a point. This vector A stands for position vector of the point to which the line passes. So I want a point. So if you see all the three coordinate axes, they passes through one common point surely, that is origin. So I can always say for all no, vector A is our 0 I cap plus 0 j cap plus 0 k cap. Nothing but it is vector 0 itself. So if I substitute in equation number 1, we are going to have this one to be vector r is equal to, this is 0. 0 plus lambda b will be lambda b vector. Okay. Now b I have to select. B is what? Direction ratios of the line. But every point on x-axis, which is of the form x comma 0 comma 0, and y-axis 0 comma y comma 0, and z-axis 0 comma 0 comma z, each and every point of this form are what? Direction ratios, and we have infinitely many direction ratios. So what to do then, because we want uniqueness? In this case, what we will do, in place of direction ratios, we'll take direction cosines. So now for x, y, z axis, direction cosines are given here. Then for positive x, y, z axis are given here, and even negative. So let's go one by one. First, I'm going to write equation of x axis. All are in vector form only I'm writing. So it will be vector r is equal to plus or minus lambda I cap. Sir, how, sir? See, don't forget when I want to write in terms of vectors, this will be I component, then j component, and k component. I component is plus or minus 1. 1 into I cap is I cap, plus or minus 1 as it is. 0 into j cap will be 0, 0 into k cap will be 0. So only I'll get this one. I hope this point is clear. Again I repeat, vector B, when I talk about, it is what? A I, okay, in this case now it is L I cap plus M j cap plus N k cap. Our L is here plus or minus 1. So put here. So I'll get plus or minus 1, and here M and N are both are 0. Okay. Similarly, equation of y axis will be vector r is equal to plus or minus lambda into j cap. Why j cap? See, y axis only y component is non-zero, remaining all are 0 there. Next, similarly, equation of z axis. What is equation of z axis? It will be vector r is equal to plus or minus lambda k cap. As you can see, only k component is present as 1. Okay, this is about x, y, and z axis. Now let us suppose particular case, if they ask equation of positive x axis, then from here you'll remove negative. That will be vector r is equal to lambda I cap. That is only plus 1 is taken. Similarly, let us suppose that they are asking equation of positive y axis. Then what are we going to write? Again from here, or I can see here for positive y axis is plus 1 y component. So it is vector r is equal to lambda j cap. Similarly, equation of positive z axis. Positive z axis is given by vector r is equal to lambda k cap. Till here I hope this is clear. Now similarly, let us go for negative part of x, y, and z axis equation. So equation of negative x axis. So again you can see for negative x axis it is minus 1 comma 0 comma 0 direction cosine. So it will be vector r is equal to minus lambda I cap. Similarly, equation of negative y axis will be vector r is equal to minus lambda j cap. Lastly, equation of negative z axis is vector r is equal to minus lambda k cap. So coming to vector form, I have given all, and it's nowhere a difficult thing to memorize. Just recall the equation of line in vector form. Point here represents a point. If a vector here represents a position vector of the point capital A through which the line passes. As it passes the origin, so I have taken vector A to be origin. So only we have lambda into vector B. And just depending on whichever the axis we want, we can just put in place of vector B the direction cosines. Okay, this is in terms of vector form. Make a note. I'm going to erase this and write the Cartesian form as well. Kindly make a note. Dear students, let us recall what is the equation of line passing through a point and parallel to given vector. It is x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C. We want to now write equation of coordinate axis in Cartesian form. Now again, x1, y1, z1 is a point through which the line passes. So as we just discussed in vector form, As you can see here, the line all passes to the origin, and the coordinate of origin is what? 0, comma 0, comma 0. Hope so it's recording. Yes. So our x1, y1, z1 all about 0, 0, 0. If I substitute here, we get x minus 0 will be, see, x1, y1, z1, x1, y1, z1 is what? 0. So x minus 0 is x divided by a, y minus 0, then z minus 0. Again, A, B, C are direction ratio, but line we have x, y, z axis. Each and every point represent direction ratios. We have infinitely many direction ratios. So we are going to take direction cosines. Those are L, M, and N. So in this, we are just going to substitute the direction cosines as per our requirement. Direction cosines of x-axis is plus or minus 1 comma 0 comma 0. So as we know that this will be our L, M, and N. So substitute here, x by plus or minus 1 is equal to y by m is 0 is equal to z by 0, or other way of writing the x-axis. See, any point lying on x-axis is of form x comma 0 comma 0. Any three-dimension point, when we talk about three-dimension, our point will be of the form p of x comma y comma z. Nothing but we are going to have three values x, y, z. So here you see always on x-axis y and z is 0. So the equation of x-axis can also be y is equal to 0 and z is equal to 0. So either this we can take as equation of x-axis, or we can take this also as equation of x-axis, and both are same actually. Just here, if you just take this two, cross multiply 0 here, 0 into x is 0. 0 by plus or minus 1 is what? 0. 0 equal to y. Yeah, 0 equal to y. Again, you take this one and the last one. 0 you cross multiply to x. 0 into x is 0. 0 by plus or minus 1 is 0. 0 is equal to z. So both are same. Next, coming to this y-axis, as we know the direction cosine is this. Oh, sorry, yeah, this is the direction cosine. So we'll have x divided by 0 is equal to y divided by plus or minus 1 is equal to z divided by 0, or on y-axis point is, you can see always x and z is 0. So x is equal to 0 and z is equal to 0. Similarly, coming to z-axis, it is x by 0 is equal to y by 0 is equal to z by plus or minus 1. Or we can say on z-axis always x and y is 0. So x is equal to 0 and y is equal to 0. I hope these points are clear to you people. Now come to positive x-axis. Same thing, just write down. Don't write now, minus 1. So the answer will be x by 1 is equal to y by 0 is equal to z by 0, or this is no change here, y is equal to 0 and z is equal to 0. Again here, positive part of y-axis, so x by 0 is equal to y by 1 is equal to z by 0, or what? For y-axis, x equal to 0 and z is equal to 0. Lastly here, coming to positive z-axis, it will be x by 0 is equal to y by 0 is equal to z by 1, or what? On z-axis, always x is 0 and y is 0. So easily we can get the results. Just the understanding of the concept is required. Now coming to negative x-axis, as you can see minus 1, minus 1, minus 1, or you can say from here, just write minus 1, don't write plus 1 there. So this will be x divided by minus 1 is equal to y divided by 0 is equal to z divided by 0, or it can be y equal to 0 and z is equal to 0. Coming to negative y-axis, it will be x by 0 is equal to y by minus 1 is equal to z by 0, or we can say x is equal to 0 and z is equal to 0. Lastly here, it is x by 0, y by 0, z by minus 1, or this will be what? X is equal to 0 and y is equal to 0. Yes, with this I have completed all the coordinate axis equation. So make sure There's nothing to memorize. What you could have orally known. No, I have just made sure written for you each and every. Okay, fine. So with this we complete the chapter. Kindly make a note. Yes, dear students, with this we complete the chapter 3-dimensional geometry. Shortly I'm going to upload probability as well. Hope so within this week. And with that, the crash course on second PUC will be coming to end, and we are going to go ahead with CET crash course. Okay, so make sure study well, be dedicated, give 100%, and perform to your best ability. Okay, so God bless you all. Do like, share, and lastly, do like, share, and subscribe to our YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you all.